Have you ever looked up at the moon and wondered how it got there? For decades, the leading theory has been the giant impact hypothesis. It suggests that about 4.5 billion years ago, a Mars-sized planet named Theia slammed into the early Earth. The debris from this massive collision eventually coalesced to form our moon. Material from Theia ended up in both the Earth and the moon, which is why their chemical makeup is so similar. This idea has been around since the first Apollo samples were analyzed over 50 years ago, but there's always been a huge mystery. Theia itself was completely destroyed in the impact, leaving no direct evidence behind. Where did this long-lost planet actually come from? Its origin has been a major puzzle for scientists. Now, groundbreaking new research is giving us some incredible answers. A team of scientists from France, Germany, and the United States have managed to trace Theia's cosmic address by analyzing ancient rocks from Earth and lunar samples brought back by the Apollo astronauts. Think of it like planetary reverse engineering. The researchers looked at specific chemical fingerprints called isotopes. Elements like iron, chromium, and molybdenum have slightly different isotopic signatures depending on where in the solar system they formed. Materials closer to the sun formed under different temperatures and conditions than those farther out. By comparing the isotope patterns in Earth and moon rocks, the team modeled hundreds of possible scenarios for the early Earth and Theia. They tested which combinations could produce the exact isotope mix we see today. The results are fascinating. The models strongly suggest that they must have formed in the inner solar system, even closer to the sun than where Earth formed. This contradicts some previous ideas that they might have come from the outer solar system. As one astronomer not involved in the study put it, what's so exciting is that we can now almost exactly pinpoint where an object that has UNT existed for 4.5 billion years came from. We're talking about a planet that was essentially vaporized. And yet, with remarkable precision, we're finally figuring out its birthplace. This research doesn't just solve a piece of the moon's origin story. It also helps us understand how planets grow, collide, and evolve in the chaotic early days of a solar system. Thanks for watching. If you found this as amazing as I did, hit that like button and subscribe for more space discoveries.